Hi, this is Craig Stocks here at Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today we're going to process some data from the M78. M78 is a bright reflection nebula in Orion, and it also has a fair amount of hydrogen either in front of it or behind it or around it. We're going to go through a couple different ways of processing it, from the very simple to the more complex. Just to show you a little bit more about it, this is a wider view showing the, there we go. There we go. So here's Orion, here's Orion's belt, the Orion Nebula, the Horsehead Nebula, the Flame Nebula. This is the Witch Head down here by Rigel. And up here around Barnard's Loop is M78, and if we take an even closer look, you can see here's M78, here's Barnard's Loop, and up here is the Boogeyman Nebula. So there's a lot of stuff going on in this region. We're of course going to focus on just M78, and we're going to do it in PixInsight and Photoshop. So let's get started in PixInsight. I'll move these out of the way. And of course in PixInsight, the first thing I do is review my data. Now in this case, I went back to my backup drive and got a bunch of old data from somewhere between 2 months ago and a year ago. It's just kind of a collection of data that I'd captured with the DreamScope. The DreamScope's usually pretty busy, especially during the new moon phase with hourly rentals. So a lot of this was probably captured with a significant amount of moonlight. But I've got all the lights set up, and of course PixInsight automatically organizes them by filter and by exposure time. And then I also have master flats, dark, and bias frames that I've loaded. And the only other thing that's really needed is to select a folder for the working files, because PixInsight WBPP generates a lot of intermediate files. So I've already run this, and let's look at the results. I'm just going to exit from here and just double click in the background to open files. And here is the swap files folder for M78. And here are this is the master folder. You can see we have blue, green, luminosity, red, and hydrogen. So I'm just going to select all of these and open them all at once. Initially, we're just going to use the red, green, and blue. So I'll open these, and PixInsight will open each one, and of course they'll be very dark because that's kind of the nature of astrophotography, that all the data is really down in the dark regions. I generally like to organize my data into a tile, so I can go to Window, Tile Windows, and it just lays them out across the screen. And the first thing I want to do, and if you're new to processing monochrome data and you're a little bit overwhelmed with red, green, and blue, it can be a little scary for people who are used to they feel the safety of a color camera. In PixInsight, it's really simple. We've run red, green, and blue together in WBPP. And all we really need to do is go to the channel combination tool. Now I have saved process icons over here on the right. This one is for the channel combination tool. And I can just put red. I can select the red file, which is right there. We're going to put red into the red channel. And then I can put green. The other way I can do this is by finding the green. There's blue, there's green. I can also grab the tab on the left side of the frame and drag it up. So there's the green, there's the blue. And notice I haven't even applied an auto stretch at this point because it's not really important for me to see it in order to follow the process of putting red, green, and blue together. Now I can click on the solid circle, and that will apply this, and it will create a new image that is the RGB combination of these. And now it might be useful to do an auto stretch and just see what it looks like. And it usually will have a color cast, and in this case it certainly does. And I'm really done with the green and blue at this point. So I'm going to go ahead and close the green and blue folders, or I should say files. And so now I have the RGB, and I've kept the luminosity, the red, and the hydrogen for use later. If I just want to process this as an RGB image, the simplest way to do it is with what you could think of as an automatic color balance or an auto white balance. If I open up the screen transfer function window, one of the icons here at the top left is like a little link. And if that's highlighted, that means that it's going to stretch with the channels linked. In other words, it's going to stretch each channel the same amount. And that's what we're seeing now. And it just turns out the green is a little bit brighter than the red and blue, so the image has a green cast to it. Sometimes it'll be red, sometimes it'll be blue. If I unclick this, then it will stretch each channel independently to about the same overall brightness, which in effect is what happens when you do an automatic white balance. So now if I apply this with the radioactive button, you can see we've got a fairly decent looking image, just with an auto stretch and an auto white balance. If I'm in a hurry, or if this is all I have to work with, or if I'm just happy with this and ready to move on, I can just apply this stretch using the histogram transformation tool by dragging the parameters using this triangle from the screen transfer function over to the histogram transformation tool. And it has copied the red, green, and blue stretch parameters to the red, green, and blue channels. And you'll notice the RGB composite line didn't change, and that's because we're not stretching it uniformly. We're stretching each channel individually. But I could now apply this, and at this point now I can turn off the automatic stretch, save this as a TIFF or a JPEG, and I'm done. It can be that easy. But I like to go a little bit further and more involved in this. So I'm going to undo that stretch that I just did, and I'm going to relink the channels. Let's go ahead and tile the windows. So here is our RGB image. Here is our luminosity. And the advantage of luminosity is it will pick up subtle details that are lost going through the individual color filters. Here is the red, and we're going to use this red filter data in conjunction with the hydrogen data because, as you will find when we get into Photoshop, the hydrogen data is contaminated with some continuous red. You can think of this central part that is a reflection nebula as having all the different colors of the rainbow, including the color of hydrogen alpha. And so that contaminates it. It's not truly a hydrogen alpha signal, it just happens to be the same wavelength. So we'll use the continuum red to correct this. So a couple things that we want to do, and I'm just going to move this, I'll just close it for now. Notice that some of the data, the camera was rotated a little bit at a different angle, and that's because, like I said, some of it was from a year ago, some of it was from a couple months ago, and the camera must have gotten rotated a little differently. So I'm going to fix that by doing a dynamic crop, something I don't like to do normally, but sometimes you have to do it. So I'm going to start with this image, and I'll go to Process, All Processes, and Dynamic Crop, and I can draw out the rectangle that I want to crop. I'll move this out of the way so we can see it. And it's at a little bit of an angle, so let's even rotate a little bit. And that will let me get a little bit more of the image. And cleaning these black edges up is important for the next step, which is going to be gradient removal. And these these black edges will interfere with gradient removal. So that looks pretty good. Now, the dynamic crop tool lets you define a crop and then apply that crop to other images. But I need to apply them before I apply it here. So to do that, I'll simply grab the triangle, drag it up to the other images that I want to apply it to, and it's going to warn me I'm going to lose the astrometric solution. And that's one of the reasons I don't like using dynamic crop. So we'll have to use Image Solver to restore the astrometric solution. But I'll just apply this to each one of these images. And then now that I've applied it to the other images, the last thing I'll do is apply it to the base image, which I'll do with the check mark. And we have now successfully cropped all of the images. So now that my next step is going to be gradient correction. And I'm going to use a little bit of a shorthand technique. I'm going to create an image container that represents all 4 of these images so I can process all 4 kind of at once. So to do that, I'll come over here to the background, right-click, and choose Image Container. And that brings up this Image Container window. And I want to load these 4 views. And this icon lets me add views. And I'll just select all. These are the 4 views that I have open. Click OK. So now those are listed. So now I can run my Grexpert saved process icon on all 4 of these at once by just dragging the triangle from this image container over to Grexpert and drop it there. And now PixInsight is going to go through and run Grexpert on each one of these images. So Grexpert has done its thing. It added a little bit of local contrast to the monochrome images, and it also neutralized the background color on the color image, so we're a little closer to a natural color. Generally, now I want to do a true spectrophotometric color calibration on just the color image. So ignoring the image container for a minute, I want to run just on this color image. First, I'm going to run Blur Exterminator in correct only mode. And again, it's from a saved process icon. And so I'll just drag that and drop it on the color image, and we'll let that run. Now that Blur Exterminator is done, I can run spectrophotometric color calibration, and we'll do that again with a saved process icon. In this case, it has the settings for the color filters, the chroma color filters in the dream scope already saved with it. So we'll just drop that onto the color image and let spectrophotometric color calibration do its thing. And actually that didn't work. We got an error message because if we look at the process console, we can see the error, this image has no valid astrometric solution. And if you remember, we did a dynamic crop, and that took off or deleted the astrometric solution. So we need to run Image Solver first, and that's under Script, Astrometry, Image Solver. And it picks up from the FITS header all of the information about where the scope was pointed and the time and so forth. So all I have to do now is click OK, and it will go through and create an astrometric solution. So now that we have an astrometric solution for this image, we can run SPCC. Again, just drag it over, drop it on the image, and now SPCC is running on that image. So now that SPCC is done, you'll notice that the look of the image has changed, and that's because the screen transfer function has not been updated. The underlying image has been changed, but the screen stretch hasn't been changed, so we want to update that. And I'm going to go ahead and open the STF parameters again, because it's important now that we use a linked stretch, because we've gone to all this trouble to do a careful spectrophotometric white balance of all the stars. So we want to be sure to preserve that by having the channels linked so that we don't inadvertently change the color away from what should be true color in the stars. Now I will come back to the image container, because the next thing I want to do, and almost the last thing, will be to run Blur Exterminator on all 4 of these images. So I'll use the image container for that, and again I'll just drag the triangle from the image container over to the Blur Exterminator process icon, and this will take about 2 minutes to run. Okay, Blur Exterminator is done. Now it's time to stretch the images. They're still in their linear state, so you can tell that by this green bar that you see next to the file name tab on the left-hand side. And what I want to do is stretch each one of these, and I'm going to do it really the easy way. There's a lot of elaborate ways of doing stretching. Because I'm going to use Photoshop, I'm going to fine-tune the tones in Photoshop. So all I really want to do at this point is have a good range of tones from very dark to very light, avoiding things that are pure black and pure white. And I can get that with the screen transfer function. I'll update. I've selected the color image, so we'll just update the screen transfer function. And that gives you a really good stretch all by itself. I will usually fine-tune it a little bit, and I'll do that by moving this is the black slider, and this is the midpoint slider, and right now it's kind of zoomed in on the scale so we can see these two. And we'll need the histogram transformation tool as well, because we'll have to apply this. So I'm going to slide the black slider over just a little, and you'll see that it's getting a little darker. I don't want anything to get to be pure black. And the core area looks pretty bright, so I think I'm going to dim that down by moving the midpoint slider to the right. Let's zoom in a little just to make sure. Yeah, we've got detail all the way there. I just want to make sure, and zoom back out and make sure that we haven't blocked up any of the blacks. If you're unsure what to do here, you're better off to do nothing than to risk doing it wrong. So I'm happy with this, so I'll use the triangle, drag that down to the histogram transformation tool, and click the rectangle, or the square I should say, to apply it, and the image will turn white. I normally just leave it white at this point, so I know I've already stretched it. And then I'll move on to the next image, apply the auto stretch. Now I'm zooming in and out on this scale, so there's zoomed out, here's zooming in. You can do it with a mouse wheel, but it's pretty tricky, and you have to be sure that you're getting in between the sliders. And then I'll move the black slider just a little. Yeah, see, this is luminosity. So again, I want to be a little bit careful of that real bright core. Better to have the image be too flat and have data everywhere. So I think I'll settle for that. And we'll apply this. Next we'll move down to the red. And again, we're not using the red directly, we're going to use it indirectly to remove the contamination from the hydrogen alpha. So again, I'll adjust it a little bit. Better to be too flat and have data everywhere. And we'll apply that. And lastly, now the hydrogen alpha. I'll update the screen stretch. Like I said, it can be a little tricky with the zoom wheel. And I want the darks to be dark and the lights to be light. And we'll do that. And I want to come back to the luminosity here. Notice, this is doubly stretched. So we've stretched the image, and then the screen transfer function is still being applied. Notice there's some areas that went pure black. I have found generally when you see that happen, especially if it's an area where you know you want to have data, that you've probably made the darks too dark. So just to correct that, I'm going to undo the histogram transformation on this one, recalculate the stretch, and try to be a little bit more careful that I don't get it too dark. So I'm going to move the black slider back a little bit. I'm going to go with something like that and see if that works better. Okay, that took care of that problem. So we're done with the screen transfer function and the histogram transformation tool. And I can turn off the screen transfer function with F12. So I'll just click on each one, press F12 on the keyboard, and that turns that off. And now we're back to our unstretched images. The last step is going to be to apply noise exterminator and star exterminator and save the stars. So I'm just going to use the image container again, drag the triangle over to my saved process container that will run noise exterminator and star exterminator, and we'll just let that run. Okay, noise exterminator and star exterminator are done, and it has created 4 new stars images. We're not going to use all of those, but it's easier just to let it create the images and then not save them. So we're done with the image container. I'll close that. This is the RGB stars, and we do want these. So the last thing I usually do with the stars is I run a little enhanced stars saved process. What that does is boost the saturation a little bit, and then it reduces green and reduces red using the SCNR filter. Now I'll save this, and we'll just save this into the that same folder with the masters. So that was in the swap files, and we'll just save that as a 16-bit TIFF. So click Save, and it should give us the save options, 16-bit TIFF. And I'm just going to minimize these that I'm not using. And now I'll go through and save each one of the starless images. Here we have the RGB image. So again, we'll save this as a 16-bit TIFF. System's a little bogged down doing the video at the same time. And now if I minimize this or iconize it, it'll automatically move the selection to the next one over. Just do File, Save As. And again, be sure to change the file type to TIFF. And in this case, I'm saving it in the same folder. And if you don't get the bit depth option, that means you forgot to change the file type. And save as. This is the red continuum, which we're going to use for continuum subtraction. And that may make more sense once we get into Photoshop. But basically we're going to subtract the continuous red color that contaminated the hydrogen alpha signal, which is the last one here that we're going to save. And as soon as this is done, we're going to hop into Photoshop and start putting all of this data back together to create an image. Because right now we just have some starless images and some separate stars, and only one of those actually has any color in it. So let's jump into Photoshop, and I want to load all of these files as layers. So I'm going to go to Scripts, Load Files into Stack, and that gives us this dialog box where we can browse for the files that we want to load. And those are going to be the ones that we just saved in the swap files master. So here are the TIFF files that we just saved. Those are added to the list, so we click OK, and that'll open them in the layer stack, which is the panel that's over here on the right-hand side. And I always keep my panels organized like this so that I have the layers in the lower right, the adjustments panel in the middle so I can quickly choose adjustment layers, and then the properties panel at the top, and that will show the properties of whatever's selected in the layers panel. So first I need to organize these, and I'm going to put the stars layer on top. We're going to have the luminosity on the bottom, and then the color, and then the hydrogen alpha. And I want to put each one of these into a layer group so that I can work with the layers with multiple adjustment layers, and basically what happens in the group stays in the group. So we'll start with the stars. I'll put the stars into a layer group with Control G. That would be Command G on the Mac. Change the group name to stars. I want to change the blending mode from pass-through, which is the default for a layer group, to screen. And you'll notice immediately now we can see through all the black areas, and we only see the stars from the stars layer. And then inside this group, I'm going to add a levels adjustment layer and a hue saturation adjustment layer, because I'll probably want to boost the color saturation of the stars a little bit. So now I can collapse that layer group with the little chevron tool, and then I'll just use the eyeball to turn it off for now. Next we have the red and hydrogen, and those are going to go together into a layer group. It'll be named HA or hydrogen or whatever you want to name it. And again, we'll add a levels and a hue saturation. And I'm going to do a couple different things in here. To start with, I've got the hydrogen above the red, so we'll start with that. Just to show you why we do the removal. Notice that there's a satellite trail or a plane trail going across. This is real easy to remove now. I'll just click on the hydrogen layer, and I'm going to grab the remove tool, which is in the toolbar over here with the retouching tools, and that gives us a brush. I can use the left and right bracket keys to make that bigger or smaller, and since I've not selected remove after each stroke, that lets me click at this end of that trail and then come over here and hold the shift key down, and when I click at this end, it draws a straight line connecting those 2 points. Now when I apply the remove tool, it'll remove all along that trail, and it's magically gone, and it has filled in with the surrounding detail. We want this to be red because this is hydrogen alpha, and hydrogen alpha is red. So we're going to use the hue saturation adjustment layer in colorize blending mode. And we want the lightness set to -50, saturation at 100%, and then we'll use the hue to decide what color we want it to be, and by default it's red, so it's already the right color. And again, we'll put this layer group in screen blending mode. And for now I'm just going to turn this off. Here is our color layer. Again, Control G. I'll change this to RGB. We won't really do much with layers in here, other than we may do a color balance and a hue saturation. And this is going to be just color that we want from this. And we're going to use the luminosity from the luminosity layer. So the RGB layer group we want to be in color blending mode, and we'll turn that off. And lastly, we'll come down to the luminosity, Control G, name it luminosity, and here we will put a levels adjustment layer inside the group. And now this is where we're going to adjust the overall brightness of the image. I said that the stretch wasn't that critical in PixInsight, and this is why. It's because we're going to fine-tune it here in Photoshop. And this looks pretty good overall, but this area is getting a little too dark. So if I turn the layers off, you can see that before I darken this, this area of dark nebula looked pretty good, and then once I darkened it, it started to get a little too dark. So I'm going to use the mask, and I'll grab my brush tool, and with black as my foreground color, And I'll start with an opacity of about 50%, which I got by just tapping the 5 key. And if I paint with black on the mask, that will hide the effect of this layer. And you can see what I'm doing. I'm just not letting this levels adjustment affect this area of the image. And if we turn on the RGB, now we've got a color image. We may want it to be a little bit darker. And in particular, this area is a little bit bright. And I think there's actually more detail in the RGB data than there is in the luminosity. So let's check that out. First, I'm going to turn off the RGB and zoom in here, and that's pretty close to being blown out. There's not much detail. If I turn off the luminosity and turn on RGB, I'm not sure it's a whole lot better. Let's start by using the RGB data though. And to do that, I'm going to duplicate this whole RGB layer group. And I can do that with a Control J. And this is going to be RGB luminosity. And we're going to focus this just in this core area. So I'll want to add a levels adjustment. And I'm going to put this, instead of in color blending mode, I'm either going to put this in normal, or I may even put this in multiplied. Yeah. Multiplied blending mode really darkens that area. Now we need to add a mask, and I want to add the mask to the entire layer group. And if I hold the alternate key when I add a layer mask, it will add a hide all layer mask that starts out black. Now I can grab my brush tool and paint with white to reveal this darker layer. And let's go down to about 20% opacity so we can build this up a little. And I'm just clicking multiple times here to build this up a little bit at a time. And I'm focusing mostly in this bright area, doing a combination of clicking and painting. That's what the mask looks like now. So we're really just letting this multiply layer is really only affecting that bright area and dimming it down. And now we'll go turn our luminosity back on. So let's go to the hydrogen alpha. I'll turn this layer group on, and you notice it makes everything red. We can tighten it up a little bit with this levels adjustment in the hydrogen alpha group by darkening the darks and maybe even brightening the midtones a little bit if we want to really bring out that red. But notice what's happened. This reflection nebula that was a beautiful blue before we turned on the hydrogen alpha has got a lot of hydrogen alpha signal in it. And that's where it was contaminated by the red continuous light. Because if we look at, let's turn off these other layers. So now we're looking at just the hydrogen alpha, and I'll even turn off the hue saturation. So it's really bright here in this red area. And if we look at our red continuum, that's where it's really bright. So what we want to do is subtract this red continuum from the hydrogen alpha. And I'm going to turn off this adjustment layer temporarily. So to do that, I'm going to first move the red continuum layer above the hydrogen alpha. Now I'm going to change the blending mode on the red continuum. And remember, this was just the red filter data that we processed in PixInsight. I'm going to change this blending mode from normal to subtract. And you can see, almost immediately it subtracted a lot here in the center. It didn't subtract much around the outside. And in fact, if I turn the red back on and turn the other layers back on, that already has made a big improvement. Now, I will usually fine-tune this, and to fine-tune it, I'm going to add a levels adjustment layer that I want to use to adjust only the red continuum. So I'm going to add a levels adjustment layer right above it. And then I want to do what's called clipping. I want to clip this levels adjustment layer to this red layer so that it's only adjusting that red layer. And I'll do that with this Add Clipping Mask icon in the Properties panel. Now, if I move the sliders on this levels adjustment, I'm only affecting the brightness of the thing I'm subtracting. And what I find typically is I will move the midpoint slider to the right, and then I'll move this lower blacks slider also to the right. And that will lead me to some kind of happy balance of hydrogen and background. And then I'll use the levels adjustment layer that's not clipped, let's just reset that, to do an overall brightness adjustment of the hydrogen. And I tend to put a lot of hydrogen into my images. And something like that. The only place I don't really like it is this dark nebula. It appears that the red hydrogen is in front of the dark nebula, and I really like the dark nebula to be a little bit more visible. So I'm going to add a layer mask to my hydrogen alpha, and I'm going to paint with a black brush, and I'll start at 20% opacity, and I'm just going to hide the hydrogen in this region. Something like that. So that's a pretty good image. We've still got the stars up here that we can turn on. And when we turn the stars on, now we have a really complete image. Typically, I would add a couple other steps. Above the hydrogen, but below the stars, I'll add some global adjustment layers, and those are typically going to be a levels, a color balance, a hue saturation, and then an almost black layer, which I have to get to by going to the little kind of a yin-yang symbol at the bottom of the layers palette and choose solid color. And I want it to have RGB values of 19, 19, 19, which I can get by using the hex values of 13, 13, 13 in this hexadecimal field. That's what the little hashtag symbol indicates, that this is hexadecimal. Click OK. And then I'll put this in lighten blending mode. And what that's doing, right now I don't think it's doing anything, but it will keep anything that's darker than 19, 19, 19 at that level. So if I start to darken the darks using this global adjustment, it's darkening down those dark areas, but it's created a kind of a limiting floor. I may want to adjust the color balance a little bit. And now I'm doing this globally, so it's affecting the RGB and everything. So, and lastly, I'll usually look at the stars. I love stars, but they sometimes are a little overwhelming. So I'm going to go to the stars layer. And first, I want to reduce the little stars. Some of these little tiny stars are just noise I want to get out. So to do that, I'm going to use the dust and scratches filter. But before I do that, I want to convert this into a smart object. So I'll right-click and choose Convert to Smart Object. Now I can apply this filter non-destructively. Go to Noise, Dust and Scratches. And usually somewhere around a 4-pixel radius with this camera works really well to knock out the little stars, but have a minimal effect on the big stars. And then I will typically add another filter with Smart Sharpen, and that restores a little bit of the fuzziness that was created with the Dust and Scratches filter. And if I think the stars are still a little bit too big, I can do one of two things. I can either go back to the dust and scratches by just double-clicking on it, and that would let me change, for instance, from 4 pixels to 5 pixels. And that'll be a little bit more aggressive on getting rid of the smaller stars. And then it re-renders all of those filters. The other thing I can do is use this levels adjustment. If I move the black slider in, that will knock out some of the little stuff, and then the midpoint slider will just darken overall. You do have to be careful. You start getting rings around stars if you darken too much. So I think that's a pretty good balance right there. There's a lot of nice colorful stars, especially over here on the left. Because of all of the nebula in the center, there's not much there. If we want to darken that bright spot a little bit more, we can go back to this RGB luminosity and paint in a little bit more of that to darken that down a little more. If we want to increase the saturation, we could go to the saturation and, for instance, target just the blues and increase the blue saturation. So you have all sorts of flexibility, and you don't have to guess what it's going to look like when you put the image together, because you can see everything right here. So, if I'm adjusting the brightness now on the luminosity layer, I'm seeing it in the context of everything else, the stars, the hydrogen alpha, the continuum subtraction. I can see it all together. So that's a basic process of M78, the brightest reflection nebula in the sky, using LRGB+Ha data. We used the luminosity data. If we just go through these layers one at a time, let's just turn everything off. So there's our luminosity data. That's what we started with. That's kind of the foundation or the background. We added the color data in color blending mode. We added some additional color data in multiply blending mode to darken this region. We added hydrogen alpha to bring out the background. We did some global adjustments to brightness, contrast, and color saturation. And then lastly, we added the stars back in. And that gives us a finished image. If you have any questions, drop those in the comments down below. And as always, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.